Getting classy with it. Concept development spotlight on analysis and reasoning. Well, when I say get classy with it, I mean the classroom assessment scoring system, of course. What does the class measure? Well, standards provide guidelines for what children should be able to do, but the class provides guidelines for what teachers should be able to do. The preschool class is organized into 3 large domains: emotional support, classroom organization, and instructional support. Within the domain of instructional support is the dimension of concept development. Concept development measures the teacher's use of instructional discussions and activities to promote students' higher order thinking skills, cognition, and the teacher's focus on understanding rather than on rote instructions. So if we take a deeper look, let's take a look at analysis and reasoning as an indicator. What you might see within a classroom? Well, experiments and problem solving as children engage with experiences. Teachers asking how and why questions to help children think out loud. Predictions, teachers supporting children with comparisons, classification, and then finally with evaluating the results and summarizing what they learned. Okay, I get it. You still need more explanation. So I'm going to use a framework we all have some familiarity with in order to explain this indicator in more detail. Yes, that's me back in elementary school with my science fair ribbon. Remember how we all had to create a science fair project? Well, it's the same steps we use in a science fair that can help us understand what kinds of strategies lead to high-quality interactions within the analysis and reasoning indicator. So let me recap the key components of the scientific method. Each of these strategies help us to support children to find more out about the world around them. So first, we have a wondering or a hypothesis. Okay? In my science fair, it was what happens to food if we just leave it out? Then, after I had a wondering, I had to gather materials in order to test it out. Next, after I gathered my petri dishes and my food, then I went about my procedure. My procedure was putting the food in different areas of the house. Yeah, poor mom. And then observing and writing down what happened to that food over time. I, made statements, wrote things down, and gathered data. Finally, at the conclusion, after 3 or 4 weeks of food all over the place, I know, poor mom, then I finally made some conclusions about what I learned with some summary statements answering the questions from my hypothesis. So we're going to use a range of strategies, the ones from the scientific method in particular, to help children to find out about the world around them. It's intentional, it's done frequently, and with depth. Oops, depth. All right, but Angela, the science fair was a long time ago. And how exactly would this translate to my preschool classroom? No worries, because we are all born understanding the scientific method. You see it every day where children make an observation. There's something on the floor. Huh. Then forming a hypothesis. I wonder how this might taste. Then, performing our experiment. Analyzing the data. Ooh. And then, reporting the findings. Yuck! This isn't food. Then, lastly, inviting others to reproduce the results. Hey, little sister, look what I found. So basically, no worries. We see this every day. That children are trying to, they're making observations, they're performing, experiments, sometimes things we don't want them to experiment with. And now we basically just have a label for what children are doing on a daily basis. So now we're actually going to use the scientific method as a way to support analysis and reasoning for young children. We're going to use the strategies such as, making observations. What did you notice? What did you see? Helping children to form questions. Okay, so they don't do this on their own. Teachers are facilitating this process. Once they formulate a hypothesis or have a wondering, I wonder what makes this door creak. Then we're going to make some testable predictions and then actually gather data on that information. Is it the actual door itself? Is it the properties of the door? Is it the weight of the door? Is it fact that the door is cracked right here in this spot that actually makes it creak? And then, once we actually test that out, then we're going to develop a theory about it. Oh, I get it. It is. When we go to other doors that don't have a crack, they don't creak. I betcha it's because it has a crack. So then we're going to actually use daily experiences within a preschool classroom with materials that are readily available. For example, balls. Do they roll? Why do they roll? How can we test this out? And then we're going to facilitate as teachers and support this process and use our own shared writing, children's drawings to actually collect data and to develop theories about what's in the world of a preschool classroom. So keep in mind, this should be very familiar to you because many of our curriculums actually support this approach, such as high scope, teaching strategies, the actual project approach itself, the work sampling system. So we are actually using curriculum to actually facilitate analysis and reasoning. So as we go back to balls, we're going to actually support children in developing their hypothesis. And it's just listening to conversations that children are having about things that are in the environment. Or it could be observing something that a child is doing. For example, a child pulling apart a ball actually means that they're wondering about it, not that they're destructive. So change your thinking about what children are doing in the classroom to help you to facilitate this process. We could talk about balls bouncing, balls rolling, what's in the actual inside of a ball, but for the example, I'm just going to focus in on how balls roll. From balls rolling, then we're going to create experiences. Those experiences are going to be in small groups, large groups, and free play. I picked balls because it's just a typical topic or a typical thing that's in the classroom, but what you want to do is hone in on what your children are interested in and what they have questions about. One teacher asked me, well, while all this scientific method is happening, what do I do about little Bobby who's eating the ball? Well, then, Bobby's telling you that he has a question about the texture of balls. Got it? So you're going to use what children are doing. Hey, there's no bad children. Really? Really? What that child is doing is showing you that they have a question. Also, you want to make sure that you're using materials and forming questions about things that children are already playing with, talking about, looking at, or manipulating. Because then they're going to sustain interest within the activity long enough in order to ask questions about it and actually go through the scientific method. So when children are interested in something, then they have the ability to attend long enough to learn. So when we're actually looking at these balls and creating experience, let's actually practice. Let's go through the scientific method. So first we have questions, do balls roll? Okay? As children are going through that experience, then you're going to facilitate children being able to, focus in on their observations, right? So now you're going to be writing down what they're saying. Okay, hey, it's rolling, look. And then you're going to be honing in on either things they say verbally or actions that they do non-verbally to facilitate the conversation further. So you're going to help them to, for example, look at the attributes of the ball. Huh, wow, this is fun. Did you notice that ball is going really fast? Yeah, whee! And through a conversation, you're going to actually move to a more detailed or more specific question about the ball. Hey, what are you noticing about these balls and how they're rolling? Children are laughing, playing. If they don't really come up with another question, feel free for you to kind of make an observation. Huh, I noticed the smaller balls are going faster. Then children will actually begin to look at that ball and look at the size. What do you see? What do you notice about that ball? Do you see something different? Pausing, waiting. Remember, this should be conversational. Try not to fire question after question, okay? As you see the child maybe hold up two balls together, then maybe you might be able to ask or say something next. Yeah, I see it too. Yeah, that ball is bigger. This one is smaller. Huh, what else? What else are you seeing? Yes, this one has a dent. Blue, blue. You're right, that one is blue. Huh, I wonder if the color makes a difference. Hey, let's try. And then you're going to have these conversations with open-ended questions. And those open-ended questions are intentionally leading children to learning. They're leading them to the attributes of the ball, the color, the texture, the shape. It's leading them to understand basic physics. How fast is the ball going? You're using positional words, up, down, behind, over, under. So these are actually academics, right, at this point. And you're either writing down children's observations. Children can tally their observations. Why do you think that? Oh, I think it's because it's blue. It's blue. It's blue, and that's why it's faster. Blue is fast. Blue is fast. And then once they come up with some words, even something as short as blue, red. Oh, you think the red ball is faster. Mary's just said the blue one. Huh. Then you're going to say, well, why do you think, Mary, why are you thinking that this ball is faster? So next you want to help children to think out loud as much as they can get out. If they don't get out a lot, that's okay. You're teaching and they're learning the process. No one has the process immediately, right? It's something that you're using as a strategy to help children to learn. Then after you kind of get them thinking out loud, 1, 2, 3, well, how do you know that that's 3? Well, does that make a difference if you put 3 balls and how fast they go? And then you may not even hear something from a child, but you'll see them put 4 balls in. And then you'll be saying, oh, now you're putting 4 balls in. So some of these children, right, we're saying the words. So hopefully over time, they begin to add more and more language to their experiences. Then you want to document what is happening. So you're gathering data. Children may say a number, or they may say a color. You're going to write that down, and slowly they do what you do. And they'll want to participate in writing their ideas down as well. Lastly, you're going to gather everything that was written, right? Pictures, revisit, maybe later during the day, or at the end of the activity, or later during the week. And then you're going to actually come to a summary or evaluation of what they learned. No, you're not evaluating the child and saying, Mary stacked 3 balls or Johnny. No, you're evaluating the learning process. What did we discover from doing this? What is our final evaluation of this process? And you're going to create summary statements. Well, 5 children thought that the blue balls were faster, but 8 children saw that the red balls were faster. And we're noticing that actually maybe all the red balls tend to be smaller. I'm wondering if maybe it wasn't the color, but actually the size. So helping children to draw appropriate conclusions from the experience. Okay, here's more examples. Pumpkins. Okay, what are your questions? What do you predict might happen if we put the pumpkin near the light? Or what do you think will be inside? Are pumpkins alive? And children, if they're developing writing skills in a preschool classroom, some children can write. Many children can draw. All children can do a tally of just a mark on a piece of paper. And then you're going to use those marks, words, drawings to help children think about what they see, what they wonder, what they think. Then you're going to actually create experiences based off of this discussion, conversation. And if you have kids like I do who don't have a lot of words, just talk about their movement and what they're looking at, or if they're like hitting the outside of the pumpkin and rubbing it. Oh, you're wondering about the texture of pumpkin. You're wondering about how it feels on the outside. And other children might be actually trying to pull the pumpkin, maybe pull off parts of the pumpkin, and then you'll say, oh, it looks like you're wondering about what's inside of the pumpkin. Based off of that, you'll create many experiences. All children don't have to do the exact same experience at the exact same time. Oh, that's a behavior challenge waiting to happen. So you're going to have experiences throughout the room. And hey, if children don't want to participate in anything with pumpkins, there's always 1 or 2. That's fine. You can ask questions and create experiments about what they are interested in. Interest helps support them to stay in the learning process and actually go through the scientific method. And you'll be listening to what they're saying to help you think of the next experience, which is why, right, you can't really do all your lesson plans until you hear what children are wondering and thinking about to facilitate the process. And then you as a teacher are using your tallies or your smartboard to be able to create graphs and data from these experiences. Oh, look at this one. Children are drawing, and as you look, this is invented spelling, so it actually is weighing, but the children are actually learning spelling words. The teachers are then going to add things to the areas based off of what children write or do. So maybe the teacher might add some vocabulary words near this chart tomorrow. But you can see the children are interested in weighing the pumpkins, so he or she already put a number chart near the piece of paper. Do you see that? So that is facilitating children to get to content learning, which is literacy, math. Remember that analysis and reasoning is leading children to new understanding and learning. So we want to know what children know, what questions they have, and here are some more examples of their drawings, right, and their observations. Tallies. What should we do now that our pumpkin is decomposing? And then follow through with another experience. Don't forget, I gave some examples about leading to learning that were very content-based. But also, children are learning social skills within a preschool classroom. That also is a great way to use analysis and reasoning. How big is my problem? Is it little or is it a big problem? What can we do? Don't get annoyed by social problems. Well, we have 2 girls, but we have 1 chair. Don't answer it. Actually helps them to think through their social problems just in the same way that you help them think through their academic problems. So keep in mind using the same strategy. We have 2 girls and we have 1 chair. Next, go into a question. I wonder what we could do. Pausing, waiting. What is around the classroom that could help us with this problem? Now these are preschoolers. I don't know. I don't know. Then maybe another child. Hey, Mary, we got a problem. We got 2 girls and 1 chair. Mary, since it's not her problem, comes up with an answer. Well, don't we have other chairs in the room? Duh. Then we go about looking for the right chair. Will this chair work? This chair is smaller than that chair. Nep. Will this chair work? Well, this is a beanbag. It is not the same as her chair. So now you're leading children to talk about the properties of chairs. You're still doing observation and you're still talking them through. So therefore, you're still coming up with ways. Well, what we're going to decide, would a timer help? What if we got a timer? You sat in a chair for a few minutes, then you sit in a chair for a few minutes. What if you both sat in a chair? What would happen? How would you feel? What could we do? That is prediction. So even when we have social problems, don't go to let's get another chair or share or right? Or you're going to have to go someone else. Actually go through the same strategies that you would for academic problems. Instead of saying something like, if you guys don't hurry up and get ready, you are not going to go outside today. Instead, ask analysis questions. What could we do to get outside early today? We could use a timer. We could use teams to clean up, right? Those are all, what would happen if we did that? What would the result be? Experimentation in a scientific method happens all day, all the time. All right. So here are some strategies that actually support my classrooms that I work with in implementing these strategies. Analysis is all about how and why and helping children to think about thinking. So they actually put the words how and why throughout the classroom. You could be more specific with putting open-ended questions throughout the room to support you in the process. What do you notice? What is the problem? How can we figure this out? What do you think will happen? Right? That's all the scientific method throughout the room. Now, don't forget, with class, depth matters. So we may start out with basic level questions. What color is that? How many do you see? And then go into more depth. How did you know it was the number 6? So once a child says something, then you want to get into helping them think about thinking. You also want to make sure your questions are leading to learning. So, how was your weekend? Is a question, but it's not a question leading to learning. It is a great question for building relationships and language development, right, to help children talk about things. But how was your weekend is not scientific analysis question, right? It's a different type of question that would fit under language modeling, for example, or, emotional support, frequent conversations. So that would fit in a different part of the class assessment. So, it can be really nerve-wracking to have someone to come in and observe all these interactions. Keep in mind that all class observers are certified and have to be certified every year to maintain consistency. Well, her wig was crooked when she came in here. I think that had an impact on my score. She was mad already. Keep in mind, just because her wig is crooked or she looked upset, all class observers are certified and reliable and have to use their own procedures consistently to make a class score. Oh, did you ever feel like this during the observation? Keep in mind, when we're talking about analysis and reasoning, it really is focused on teachers. So analysis and reasoning in the manual says it's really looking at the teacher's use of strategies to encourage understanding and thinking skills. So in particular, analysis and reasoning doesn't really look a lot at the children's behavior per se. So when children act out, hey, it happens. Don't feel overwhelmed or stressed. Just keep doing what you're doing and talk children through, and know that it's not necessarily always how the children are behaving, but how you respond to it. Now, after you've had an observation and received your class scores, well, I did exactly what Angela said, and I got a low score. Tell me about that, Angela. Well, keep in mind, the class observation tool is about frequency. I like to call it dosage. Dosage matters. If you're sick and you give just a little bit of medicine and not the full amount, well, honey, you could still be sick. So, the class looks at depth, as we mentioned earlier, but it also looks at dosage. How much you're doing something. Yes, you already do this, but how frequent is it? So, is it, within a 20-minute observation? Does it happen once? Does it happen many times? Is it consistent amongst all the teachers in the classroom? Remember, class, right? Don't take the class out of the classroom assessment. It is a classroom observation that looks at all the adults in the classroom. Yes, it looks at ways, right? Gives different weights between the lead teacher or someone who's leading an activity or how many children they're working with. But it does look for, is there consistency amongst all the adults? If you're looking for high scores, well, one of the things you also want to look at is how consistent, how effective, and how frequent you're actually using these teaching strategies. So the class looks at lots of different things. So if you're already doing it, do it more. If you're already doing it, is everyone doing it to the same level, to the same depth? And how are children responding? Is it effective? So keep in mind, there's no such thing as bad data or bad scores. Use it as an opportunity to learn and analyze your scores. Sometimes scores can vary based off of the time of day. Were you fresh in the morning or were you tired in the afternoon? The number of children in the classroom. So also look towards, it says on the summary report for the class, on the number of students, the number of adults can make a difference. The activity itself is a routine, like getting dressed or going to the bathroom, or is it whole group? Keep in mind that observations can take place throughout the entire day, including routines and experiences. For preschool, the only time we would stop observing would be during unstructured outdoor play. Also, keep in mind the day of the week during the observations. Whew, those Mondays, boy, can they be hard. But that just means you want to be more intentional on Mondays. Want to learn more about, project-based learning? I actually created a playlist of project-based learning examples on my YouTube channel. There are about 38 examples for preschool children that you can access. Want to learn more about class? Well, Teachstone, who created the class assessment, has a great blog. So don't forget to go to teachstone.com and check out their blog. Want to ask me some more questions? Feel free to contact me. I'm an affiliate trainer for Teachstone and also a member of the Class Community Advisory Board. Lastly, feel free to also connect with me on social media. I hope you enjoyed our time together.